NEET 2025 didn't go as planned.
535 marks.
बस थोड़े से मार्क्स से रह गई। बायोलॉजी ठीक था, केमिस्ट्री भी, पर फिजिक्स वो फिसल गया। इस बार पढ़ाई नहीं, तैयारी करो, वो भी स्मार्ट तरीके से, क्योंकि इन्फिनिटी लर्न लाए हैं अट्रेया, इंडियाज मोस्ट पावरफुल नीट रिपीटर्स प्रोग्राम विद P2CB, जिससे फिजिक्स पे होगा डबल फोकस।
Don't just make it your last try, make it your best one yet. Join Infinity Learn today.
Hi, good morning my dear children. Welcome to one more amazing session from Infinity Land. This is Suresh, Faculty of Chemistry. And welcome to the NEET Nirman program. How are you all doing? Today we are going to discuss about chemical bonding, especially for the covalent bond, and VSEPR theory is going to be the most amazing topic, and this is a topic of interest for today. How are you all doing? And please like the session and share with your friends and subscribe to Infinity Land YouTube channel. I just want to take a confirmation from you. Am I audible? You all able to can see me, can hear me? Just give me a thumbs up and fire emoji. Hi. Hare Krishna. Yeah. Hi. Hare Krishna, can you able to hear me? I can't see the font. I can't see the font there. Okay. Dear children, in this, yeah. Thank you very much. Let us start without any time delay over here. And today topic of interest is going to be chemical bonding, VSEPR theory and shapes of molecule. I just want to give you some tricks and tips as well. And before going for that, little promo over here, and those who did it NEET examinations, congratulations, and those who are trying to take a drop for this year and preparing for NEET examination 2026, and this program is for you. Infinity Learn by Sri Chaitanya Academy is launching Atreya program. In this Atreya program, we want to change you. Let's change the scenario. I didn't do well and I'll change, and Infinity Learn want to transform you guys into the situation, and I will do it. And because we have the Atreya program, P2CB program, in this P2CB program you can see physics twice a day and chemistry and biology every day. And you see, when you attempt the question paper of 2025 NEET examination, it is going to be physics and chemistry and biology. Biology theek thaak tha and chemistry be okay chalta, and when it comes to the physics, it is going to be slap like anything. And it's not only you, dear children, not only you individually, but also the physics is going to be nightmare. सब बच्चों को फिजिक्स का बहुत लड़ाई चल रहा है, and we want to come across with a conclusion for how to crack the physics. So India's most powerful NEET repeaters program emphasizing on more on physics. Here you can see in this program Atreya, it is a revolutionary NEET preparation program for the NEET repeaters, and you're going to see double focus on physics along with chemistry and biology. So we'll start just one more minute. Hare Krishna, one more minute. Okay, and enroll now. The link is there in the bio link, and you can see in the description box in the pinned messages also. You can click and enroll yourself. Just little details about this program, and this program is commenced May 23, and every week a new batches are being launched. So you can enroll in a new batch bacho, and days of the week with classes, Monday to Saturday programs are there. In that 1 hour 30 minutes in each session, every day 3 sessions will be there bacho, and 2 concept sessions and 1 practice session. And you are going to have classes per week. There will be 18 classes per week and double practice class for the physics. So, and you have interactive classes, 465 classes per a week, per a total program, and you have 240 DPPs. Yeah, it is fees. You can just click the link and the fees will be displayed. and dedicated practice classes, 120 practice classes there along with your faculty, and that is practice class. And for practice class you won't be given a big batch. So a small batch of 20 to 25 students will be allocated, so that you will be having a good discussion with your faculty, and a customized doubt removal session will be there, and also total coverage of 11th and 12th syllabus. So my dear children, and the last slide, those who completed your NEET examination, you just provide the link, and link is given, and click the link and provide your details, so that ताकि आपका चलेगा एम्स, जिपमर, AFMC, government, top medical college, and wherever chance is there, we are going to provide you data for that. And this today's session is all about the chemical bonding. So promotion is over, my dear children. In this, today we are going to talk about chemical bonding. In that chemical bonding, what are the major important topics? Why? Because this chemical bonding is the backbone of the total inorganic chemistry, which carries 30 to 33% of the total NEET examination. Therefore, you be clear with periodic classification of elements and chemical bonding, so that 30 and 33% of the paper will be in your hand with a total grip is you. So every question and every mark does matter, because you are competing with your 25 lakh odd students, right? For that, so you have to run in the competition range. So let's talk about the topics that are more important in this chemical bonding is electronic theory of valency, Lewis octet rule, and ionic bond and covalent bond, and VSEPR theory, valence shell electron pair repulsion theory, and valence bond theory. In that you see the hybridization and molecular orbital theory. At the end, hydrogen bonding and bond parameters. Dear children, if you see these parameters, you can see this is completed in the previous class, this is completed in the previous class, and today's class of interest is going to be VSEPR theory, right? And if you have a question from this NEET examination, bacho, you can expect a question here, and you can expect a question here, and molecular orbital theory and bond parameters. So you tell me which topic you feel so difficult, so that आगे आने वाले के जो classes है ना, ये topic के हिसाब से मैं schedule करना पड़ता. So Hari Krishnan and other students, and if you feel any of these topic you feel is most difficult, please let me know in the chat box, so that I can schedule next upcoming session based on your requirement. This is a NEET YouTube channel by Infinity Learn, and it's a live interactive session, and in this live interactive session you can discuss the topics and the doubts with me, and I can also interact with you. It is not a radio telecast session. So with an expert faculty, you want to attend a class like this, you have to travel a long distance and you have to pay huge money. But here this session is absolutely free on YouTube channel, quality lesson and the quality session is going to be delivered. If you have any doubt, you can ask. So this is absolutely free, we don't expect anything. So we are doing this service for the benefit of the students. So we don't expect anything except expecting just a simple like and share and subscribe to Infinity Learn NEET YouTube channel. So let us start, starting from chemical bonding. In that covalent bond we'll see. Right, Betam? Any doubt? Any doubt? One thumbs up and fire emoji so that we can start the class. Promo is over, introduction is over. Directly we'll go into the concept. Hari Krishnan, come on. Give me a thumbs up. All students, so let's talk about a covalent bond. What is a covalent bond? So we can use the Lewis dot method. In the covalent bond, it is a bond formed by mutual sharing of electron. I am starting this class right from the scratch level, however you know it well and good. And you can see hydrogen has one electron, he is going to bind with another hydrogen, so that a 2 electron is acquired, so that helium configuration. According to Lewis theory, so the element atom should participate in the bonding to get 8 electrons in the outermost shell or 2 electrons in the outermost shell. If it is 8 electrons, it is said to be octet rule. If it is a 2 electrons, it is going to be duplet. Among this octet and duplet, which is more stable? as duplet is more stable. So that hydrogen got helium configuration, that is a duplet configuration. Hydrogen fluoride, hydrogen has duplet configuration. After binding, fluorine has 8 electrons, it is an octet configuration. It is also stable. Chlorine and chlorine, it is also having an octet configuration and it is octet configuration. So octet rule says that an atom must possess 8 electrons in its outermost energy level, and thereby it is going to get a stability. Bachcho, you have 8 electrons wale, that is, you can say it is octet. If it is a 2 electrons scenario, it is called as a duplet. So among octet and a duplet, which is more stable? Which is more stable, you tell me? Duplet stability, duplet is more stable than octet. That's the reason why helium is more stable than neon. Are you getting or not? So we'll see, is everybody, every compound in the chemistry is participating in bonding? Yes, of course, except noble gases. And once they get a compound, all atoms obey octet, may or may not be. Then how do you say? The chlorine, this we discussed, polar and non-polar covalent bonds. If a bond is formed between two similar elements, atoms of a same element is going to have the non-polar bond, because the electronegativity difference is going to be 0. When the electronegativity difference is not equal to 0, there will be some polarity between the bond. And the polarity of the bond is the key point in every chemical reaction, my dear children. That is just a tricky point. Even in the organic chemistry, you just see big mechanisms. In that big mechanism, you are going to break the bond where the polar bond is there. The polar bond is the weakest bond as compared to the non-polar bond, my dear children. This is the tricky point. So in between two same non-metal atoms, equal sharing of electron pair takes place, and the bond formed is a non-polar covalent bond. Example like oxygen, hydrogen, chlorine kind of things. Okay, nitrogen Ba. Then what is a non-polar? Yeah. So what is a non-polar? So in between two different atoms, non-metal atoms, unequal sharing will be there. So because of the unequal sharing, the electron pair has to move towards a more electronegative atom. Therefore, there will be partial charges acquired between two atoms, that is said to be a polar bond. So there should be two different elements. Then it's said to be a polar bond. Okay. So molecules like H2O2 and H4 possess both polar as well as non-polar bonds. Yes, it is true. And talk about incomplete octet and hypovalent. Incomplete octet वाला है, less than 8 electron वाला आता है आपका incomplete octet है. Okay. In this scenario, you can see in some compounds the number of electrons surrounding the central atom is stable molecule, but fewer than 8 electrons. So actually this is said to be hypovalent, and Lewis octet rule failed to explain why this is going to be stable. That we can go for hybridization and we can discuss with that. Okay. And you can say beryllium chloride, boron trifluoride, aluminum trichloride comes under this. You want to say beryllium, how many electrons are there? Be interactive in the chat box, you can talk to me, and I am asking you a question in the chat box, you just tell me beryllium. Beryllium is going to be 1s2 and it is 2s2. Outer shell has just 2 electrons, so that beryllium has just 2 electrons. This is an electron here and this is an electron here. And you see the chlorine has 1s2, 2s2, 2p6, 3s2 and 3p5. So total 7 electrons are there. So chlorine has 7 electrons. So that chlorine has 7 electrons. This session now we are talking is helpful for those who are in the grade 11, grade 12 and the droppers also. Sir, fundamental पढ़ा रहे. So this is the fundamental concept. After this, I just want to talk directly about VSEPR theory. Mind it, today's topic of interest is about VSEPR theory. As it is said to be 7 electrons, 1 and 2 and 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6 and 7. So chlorine has 8 electrons and chlorine has 8 electrons. And beryllium, you can say how many electrons better? It is going to be 2 plus 2, 4 electrons. It is less than octet. Yes, it is less than octet. However, it is as a less than octet, it is going to be stable. I just want to mention a trick. Bacho, everybody, mind it, trick. Which of the following is not obeying octet? Any beryllium compound, any boron compound or electron deficient do not follow octet. Okay, and it could be third period elements also superoctet hoga. Let's talk about the expanded octet or hypervalent. This is called hypervalent. Hypervalent का क्या होगा? Greater than 8 electrons होगा उसके लिए. Understand? Very important thing, dear students, follow this. And there are more than 8 electrons around the central atom. The number of the electrons is going to be more than 8 with the central atom, or called superoctet or extended octet or expanded octet or hypervalent. In that case, you can say phosphorus, pentachloride, sulfur, hexafluoride, iodine heptafluoride. So phosphorus pentachloride, you can see phosphorus, it has 5 electrons. And if you see the chlorine, you are going to have the bonding like this. Ten electrons will be there. 10 electrons will be there. So 10 electrons is going to be, phosphorus has 10 electrons, is going to be hypervalent. Of course, this is also stable. And we'll discuss about more details about this. Right? And odd electron molecules. Odd electron molecule. Some molecules contain an odd number of electrons like NO and NO2 and ClO2. This is very, very, very important. In the NEET examination, bachcho, you will be asking which of the following is hypovalent, which of the following is hypervalent, which of the following is an odd electron species. Now you can see nitric oxide. Nitric oxide, it has 5 electrons in its valence shell. It has 6 electrons in the valence shell. दोनों मिलके आपका 11 electrons होगा, which is an odd electron species. Actually, when a bond is formed between two atoms, ये electron देते हैं, ये electron देते हैं, so it is going to be a bond pair. So always the bonds are in the even number, but here in the case you are going to see odd number. Odd number is rare cases where you can see. Definitely in the NEET examination, multiple choice question. Please take a pen and a paper. As the class is going on, you are going to get a very good noteworthy points. Understand? Clear? Students, very important points I am giving you. So formal charge. So the formal charge is very important to calculate to find the actual Lewis structure. And when you write the resonating structures, you will be able to identify which is the possible and correct resonating structures by checking the formal charge. And this formal charge can be calculated by using the formula. Formal charge is equal to Na minus Nm. What is Na minus Nm? Na is the number of valence electrons of the free atom electronic configuration का हिसाब से. According to the electronic configuration, number of valence electrons, you write it. Then Nm is the number of valence electrons belonging to the atom in the molecule. That can be calculated by using number of lone pairs plus 1 by 2 into number of bond pairs. So the sum of the formal charge is supposed to be equal to 0 for a neutral molecule or the sum of the formal charges of every atom is supposed to be equal to the overall charge of the ion. So based on that, the formal charge is very important in calculating the to identifying the actual resonating structure. Students give the less emphasis on the formal charge. This is important. The charge on the formula, structural formula of the molecule, that can be calculated by using this simple algorithmic formula, right bachcho? So moving ahead, which of the following is odd electron species? You tell me. I want you to give the answer. After this I will start VSEPR theory. My dear students, come on. My dear students, come on. Right. Here you just identify the number of valence electrons here. So trick, 6 electrons from the sulfur, oxygen has 6 electrons, from the valence cell 2 oxygens are there. So it is going to be 18. It is an even number. It is an even number. Question is asking about odd number. Here it is going to have the odd number, because it is 7 plus 6 into 3. It is an odd number, right? So like that, simple, use the trick. Don't put all the structures. You will identify which of the following has an odd electron. मैं क्या बोल रहा? So this is a NEET typical model questions. You can find out this kind of questions has been asked in the previous NEET examination. Hey, no? Yes or no? Right. And if you have any doubts, please let me know, my dear students. Please use the chat box, please let me know. And which of the following molecules obeys octet rule? I already given a trick. Any boron compound and beryllium compound has less than 8 electrons, and the third period element has 8 electron greater than this. So based on that, you can say it is electron deficient, less than 8 electrons, it is less than 8 electrons, it is greater than 8 electrons. So, and it is going to be 8 electrons. So it is octet sufficient. Understand? So you see, it is a practice. When you attend a NEET YouTube channel, you are going to have a lectures from the physics, chemistry and biology, and you just take a pen and a paper and check yourself how you are doing, what is your strength and what is your improvement area. Students, attending the YouTube channel means simply you feel it like surfing, but here in this particular 2024 and 2025, I strongly recommend the students rely on the YouTube channel. And in the YouTube channel, you can just see in the 2024 and 25, I can find a dozen of students in my own account, those who attended just free YouTube classes got the medical seats. Can you believe it? 650 plus bhi mila. And you can get a medical seat simply by attending my YouTube classes, Infinity Learn YouTube classes. Okay, yes, aap sahi suna. And this NEET YouTube classes not only useful to crack the NEET examination, but also you can be a topper. And can I say one thing? One of my office boy, he is just moving here and there and doing office works, but he prepared YouTube classes and cleared your GIE examination also. And it is there in the NEET channel. It is there in the Infinity Learn JEE channel as well. And there are some winner stories. And wherever you are there, my dear children, strongly I recommend you can go to any Sri Chaitanya Academy nearby, and physically you attend there and talk to the counselor there. You can get a sample paper. They don't charge you. They'll get a sample paper and you can solve it. If you have a doubt, you just give the reference of NEET YouTube channel and Infinity Learn, and you can go and get a doubts clarified. You just visit, not an issue at all. So here Sri Chaitanya Academy is going to give a service to the best. And as a part of these operations, we are giving some courses and you can pay and join, that is your interest. Okay, nitrogen trichloride है ना, Nitrogen trichloride is NCl3. So, all which of the following obeys octet rule? Yes, NCl3, Hari Krishnan, it is going to trichloronitrate hai. No, nitrogen trichloride, because electronegativity, electronegativity of nitrogen and chlorine बराबर होता है, ठीक है, नाइट्रोजन क्लोरीन बराबर होता है, ठीक है बेटा. And you can talk about this is the 3, and you can say physical state and talking about the properties of the chemical covalent compounds. You are going to say under normal conditions of temperature and pressure, covalent substances exist as gases or volatile liquids. Okay. In that, do you find any solids in the covalent compound? Do you have any exceptions there? Do you have any exceptions there? Yes, we have graphite, we have diamond, you have aluminum nitride and boron nitride polymer. You know, boron nitride polymer is giant polymeric structure. So, its strength, you know, it is just like a diamond. You know, boron nitride is also called as inorganic graphite, and it is also very important compound. We will discuss in the P block elements boron family. So, stay tuned for such type of lectures. Okay. Now, you can say melting point and boiling point is completely opposite for the ionic compounds. Ionic compounds has more melting point, high melting point and boiling points. Relative to that, covalent compounds has less melting point and boiling point. Understand? And they have low melting point and boiling point because they have the weak van der Waals forces. Okay. And talking about the physical state, I already mentioned here. So, solubility. Organic compounds, or you say ionic compounds, are readily soluble in the polar solvents like water, while you see covalent compounds are not actually soluble in the water but soluble in the non-polar solvents like organic solvents. Can you say some exceptions where a covalent compound is easily soluble in water? Yes, glucose is organic compound, pure covalent compound, soluble in water. Sucrose, table sugar, you all every day we dissolve in the water, it is soluble in the water. Ethanol is soluble in the water. So, the ammonia is soluble in the water. And how it is possible? Yes, there is a concept of hydrogen bonding because of the extensive hydrogen bonding between the compounds like this with water, or in any cases of ionization takes place. In that case, covalent compounds are soluble in the water. Acetic acid is soluble in the water because it ionizes. Yeah. Thank you, Hari Krishnan. Please like the session. Please like the session. Thank you very much. When the session is about to start, you only urged me, sir, please start, sir. Now you are enjoying my lesson. Thumbs up. One thumbs up. Okay, you like the session? And in the link it is available. You can subscribe to this channel so that whenever my classes comes now, it is going to be given a notification to you also. Bell button dabao, jaldi. Okay, now isomerism. Yes, ionic compounds are non-directional. Yeah, thank you very much. Ionic compounds are non-directional, whereas covalent compound has a direction. Therefore, it is going to show a space isomerism. Space isomerism क्या होता है? Stereo isomerism will discuss in the organic chemistry. Get ready for the organic chemistry. Amazing sessions will be there with a lot of animations. Okay. So, coordinate bond. It is a special type of bond. This is also said to be a dative bond. So, based on this dative bond, my dear children, complex compounds, a separate chapter is there in the class 12. Right? Okay. We will discuss about that. Complex compounds in the future classes. Now, let us talk about the dative bond. I want to tell you a story. If two friends are there, so they are going to a bakery and purchase a piece of cake. So, in that story, every day, friend A and friend B, okay, he gives a 10 rupees, he gives a 10 rupees, and both are sharing the 20 rupees cake. That is called covalent bond. सो अच्छा तरफ कहानी भी सुनाई देंगे आपको. सो ए dative bond होता है क्या? So this is called coordinate covalent bond. In this dative bond, so next day scenario is changed. So friend A and B, A has no money and B has money. So they went to the bakery. B contributed total 20 rupees. And their friends now, they purchased a piece of cake. Still they are sharing equally. So what is the moral of the story? In the story number 1, mutual sharing. In the story 2, B is contributed and both are sharing. So coming to the coordinate covalent bond, it is a type of special type of covalent bond where one atom contributes and both atoms share. You can say one atom completely donate and another atom accept. If that is the case, it is going to be ionic bond. Of course, bachcho, this is a very important, fantastic bond. Coordinate covalent bond or coordinate bond is a special type of covalent linkage or bond which is formed by mutual sharing of pair of electrons between two atoms, but the pair is contributed by only one atom. This is what is called as a covalent bond, and donor atom act as a must have at least one lone pair. ये देने के लिए कम से कम इसके पास एक इलेक्ट्रॉन का जोड़ी रहना पड़ता, एंड एक्सेप्टर जो है इसका पास एक वेकेंट ऑर्बिटल रहना पड़ता है ताकि इसका डोनेटेड इलेक्ट्रॉन शेयर करने का इसका जगह दे सकते हैं. एंड यू कैन से यू कैन yeah. So here an atom to act as an acceptor must have an empty orbital. So that I just want to say it is connected to Lewis acid base theory as well, and it is said to be Lewis acid. And a donor should have one lone pair of electrons. It is going to be donor. It is going to be Lewis base. Right? Hare Krishnan, you can see here H plus empty orbital is there, BF3 empty orbital is there, AlCl3 empty orbital is there. Okay, and you have SCl, H2 and NH3, and you can have NH3 is having a lone pair of electrons. Okay, and this is going to be donated to the vacant orbital, so that there is a bond between nitrogen to hydrogen to form ammonium ion, right? Similarly, H2O, water is a neutral, and one of the electron pair is donated to the H plus of this is going to have H3O plus. This is called hydronium ion. These are all real time existence, and this dative bond is shown by using a direction arrow mark. And you can see that polar covalent bond, coordinate covalent bond is a polar coordinate bond. And some other examples you can see in the carbon monoxide, you can see the HNO3, you can see the complexes, you can see I3 minus as well, I3 minus as well, understand? Okay. So ozone also, sulfur dioxide also, sulfur trioxide also. Please take a pen and paper and you can add a point in your note. And properties of the covalent compounds or intermediates of ionic and covalent compounds. You can see ionic covalent bond and coordinate covalent bond. And see the difference between these three. Ionic bond between ions are very strong. And you can see covalent bond between molecules it can happen, that is a covalent bond, and between the molecules just maybe van der Waals forces of attractions will be there. That is intermolecular force, we will conduct a special session for them. And coordinate bond in between the same, and you can see melting point and boiling point, and condition, you can say conductivity, solubility, solubility in water, solubility in non-polar solvent, everything in physical state. And you can take a just a screenshot so that you can have a reference material for that. Everybody take a screenshot, Click quickly. Yeah. And the correct order of decreasing polarizability of the ions, you tell me. This is Cl minus beta, this is Cl minus, okay. I want you to give the answer. In my class, concept will be discussed. After that, this concept, a question will be discussed. So, real time NEET preparation is happening in my class, mind it. So, my dear students, polarizability, trick देना आपके लिए, trick देना, polarizability. So, polarizability is directly proportional to size of anion. It is directly proportional to size of anion, right? So, size of anion, you can see, it is going to be I minus greater than Br minus greater than Cl minus greater than Ef minus. ठीक है? Then I want to say polarizability. It is going to be the same order. So, I minus and Br minus and Cl minus and F minus. So, I want to say C is the correct answer for this question, you can say. Got it? Fine. Now, which of the following has highest polarizing power? Actually, my dear children, I just want to say, this is the cation and this is the anion. So, because of this, cation is going to attract the anion like this. This is called polarization. In this polarization, cation is attracting this anion. He has this is the cation. Bacho, this is the cation and this is the anion, my dear children. So, in this cation, he has a power to attract. So, polarizing power is size of cation, and he has the ability to get polarized. So, polarizability is directly proportional to size of anion. Now, you can say polarizing power is directly proportional to the charge. बच्चों, जिस कैटयन का चार्ज ज्यादा है वो कैटयन का पोलराइजिंग पावर ज्यादा होगा. +2 +3 +2 +1 कौन सा कैटयन का पोलराइजिंग पावर ज्यादा से ज्यादा होगा? I want to know. Hari Krishnan, you are going to get option B as the answer. So, displaying the question and displaying the answer is not the matter here. Displaying the question and explaining the concept is the class. My dear children, please take a pen and paper and attend the class with a lot of enthusiasm. Now, talking about the day conference here, the VSEPR theory, valence shell electron pair repulsion theory. Everybody raise. And so, the shape of the molecule is based on the VSEPR theory. It is a procedure. It provides a procedure to predict the shape of the different polyatomic molecule. So, a shape, क्या करता है ये shape हमको? A chemical reactivity and the physical property, chemical property of a molecule is based on its shape, mind it. It is based on its shape. Its shape has its own interest of identity. You can see the shape of the molecule is based on the number of electron pairs present in the central atom of the molecule. Okay, the number of electron pairs, agar 2 hoga to it is going to be linear. Electron pairs, jodi. Always, according to this VSEPR theory, bachcho, A polyatomic molecule, the atom present at the central of the molecule is called central atom. This central atom has a valency shell, and the valency shell has electrons always in pairs, jodi jodi. Okay, these pairs are lone pairs and bond pairs, and these pairs decide the shape of the molecule. And these pairs are two types. One is a lone pair of electron, another one is a bond pair of electron. Bond pair of electron is the pair which participate in bonding. Lone pair of electron do not participate in bonding. So bond pair is more stable and occupy less space and cause less repulsion. Whereas lone pair is going to occupy more space and causes more repulsion. And the central atom has the electron pairs arranged around its space in such a way that repulsion among them is minimum, so that it is going to give a particular shape or a geometry, and that is explained on the basis of the VSEPR theory. If two electrons are there, let us say A is the central atom, it is bonding with to the B and it is bonding to the B, and it is going to be 180, it is fixed. There is no lone pair of electrons in this scenario. It is going to be the linear, and it is going to be triangular planar. You can say A is B and B, it is going to be TGBP, triangular planar. Got it? And it is going to be tetrahedral if it is 4, and you can see A and B and like this, B and B and B. It is a tetrahedral. The angle is going to be 109.5. So it is going to be tetrahedral angle, this value. And you can see the shape of the molecule that is discussed here. The repulsions among them is lone pair causing repulsion on a lone pair is greater than lone pair repulsion on the bond pair is greater than bond pair repulsion on bond pair, right? And the presence of lone pairs on the central atom causes a slight distortion, mean to say bend. And the bond angles from the ideal shape. Previous one I discussed, these are the ideal shapes. These are the ideal shapes. And these are the ideal bond angles. And these are deviated. And this deviation is explained in this point. If lone pair is introduced, it is going to have a distortion and you are going to have a deviation. We are going to discuss about that, and I already explained this point. Molecules with no lone pairs on the central atom. You can see Ab2, beryllium chloride. So in the beryllium chloride you can say, just say BaCl2, beryllium, it has one electron. You have a chlorine, it is going to have a chlorine, it is going to have 7 electrons like this. Chlorine, 7 electrons like this. Okay, now dear children, you consider this is a bond pair and this is a bond pair. And consider the electron pairs with respect to the central atom, not on the bonded atom. So when these two are there, they can be arranged in 180s ताकि इसका repulsion ये दोनों का बीच में कम से कम होगा. So it is going to have a linear shape. It is going to have a linear shape. This is a linear and this is bond angle is 180 degrees, right? And you can see Ab3 boron trifluoride. Boron, you can say 3 electrons are there. And you have a chlorine, and you have a chlorine, and you have a chlorine. So the bond here, it is going to be a bond, it is going to be a bond, it is going to have a bond, it is going to be trigonal planar. Trigonal planar. So this is going to be TGB, DGB, right? And you can say AB4 methane you can take. it is going to be a tetrahedral. Carbon, you know, all this is going to be, carbon is tetravalent, na? 4, and hydrogen is going to be here 1 electron, hydrogen is going to be 1 electron, hydrogen is going to be 1 electron, hydrogen is going to be 1 electron. You are going to get here a bond, bacho, you can see learn like a dummy and write the exam like a pro. Believe this feeling? When you prepare, learn and practice like a dummy, you feel as if you know nothing and you learn it. When you write the examination, write like a pro, because once you completed all your concept, you are going to get a pro, right? Dear children, this is very important. You can see it is going to be tetrahedral, right? So it is going to be 109.5. This is going to be tetrahedral. Okay, and here you can see here 109.5 hoga, not 8 दिख रहा है ना. Okay, right, fine. और एक है, now you can see AB5 phosphorus pentachloride, इसका structure आता है. Now how do you draw this? Phosphorus, dear phosphorus, it is going to have a chlorine and it is a triangular structure. You can see this is your triangular structure. In this triangular structure, this is going to be planar triangular structure, right? You can see a planar triangular structure. And you see, you can see here a chlorine is there, perpendicular to this and perpendicular to this is a chlorine, so that you are going to experience a pyramid over here. You can see a pyramid, it is a pyramid on that triangle. Bacho, carefully you see. And also down here और एक pyramid दिख रहा है आपको, और एक pyramid नहीं दिख रहे? Yes, it is going to be और एक pyramid है. So 2 pyramids are there. Okay, 2 pyramids are there. It is going to be trigonal bipyramidal. This is going to be trigonal bipyramidal. This is, you can say, TGBP. Can you say here 2 types of bonds are seen? 2 types of bonds. This is a bond going to the equator of the triangle, that is called equatorial bonds. And this is a bond which is coming on the axial position, so it is said to be axial bonds. A stands for axial bonds, and they are longer. And you can say equatorial bonds. E stands for equatorial bonds, that is going to be short and strong, and axial bonds are going to be long and weak. So this is very important. Actually, this is a phosphorus pentachloride PCl5. These PCl5 structures in the gaseous phase or in the vapor phase appears like this. Students, if you have any doubts, you tell me. I am going to ask you what is the structure of PCl5 in the solid state. Sir, want to join Infinity Learn test series? Please tell me the process. Okay, dear children, please mention in the comment box. I will mention you. Please write in the comment box. Write in the comment box. I am going to provide you the information. I will send you the information. Okay. Meeta, hope you are enjoying the class. In the comment box, it will be recorded. Otherwise, this live chat now, it goes like this. Fine. Mention and please like the session. एक बार like मारो बच्चों. Take a snapshot. Okay, right. Now let's see some more details of here. AB6 sulfur hexachloride. It is an octahedral. It is an octahedral, and it is an octahedral. SF4, SF6. So you are going to see hexagonal structure, and this is a octahedral. Now you can see how many faces above the square. 4 faces are there. Below the square you can see 4 more faces. So as a result of this is going to be 8 faces. So it is going to be octahedral, stable. It is a stable, and all the bond angles in the speciality you can see 90. All bond angles are 90. In the NEET examination, bachcho, NEET examination, you will be asked a tricky questions like how many atoms are there in one plane? How many atoms are there in one plane of SF6? Maximum atoms are there in one plane of SF6. So you can see this is and one plane, this is in one plane, this is in one plane, this is one plane, total 5 atoms are there. So like that you just study the structure, don't by heart the structures. By hearting is useless. You don't get anything. You get nothing by hearting. Rather you just study. That makes it very, very, very important. Okay? Chalta? ठीक है? Right. Now you're going to say NCl3. Various structures I just want to say. It is going to be total valence electrons are 26, and requirement is 3 sigma bonds and 1 lone pair. Hybridization by mix karna padta, so that it has a 4 sp3 hybrid orbitals. Shape is going to be pyramidal. NCl3, explosive. It is explosive, right? And you can say BBr3. When you talk about the BBr3, so it is going to be total valence electron 24, requirement 3 sigma bonds, undergo sp2 hybridization. Shape is going to be planar triangular. And you can also say silicon tetrachloride is going to be tetrahedral. It is going to be sp3 hybridization, tetrahedral. Study with the valence shell. You will understand here. You can see ICl4, SF6, BF2. You are going to get ICl4, it is going to be tetrahedral, and SF6 is going to be square bipyramidal or octahedral. Both are permitted. Generally it is mentioned as octahedral. Okay, and BF2 is going to be the linear. It is going to be linear, right? And CLF3. My dear children, a very, very, very important CLF3. In this CLF3, bachcho, chlorine has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Here it is going to be fluorine, a bond. Here going to be fluorine, a bond, and here is going to be fluorine, a bond. When you see this bond, there is a bond, and there is a bond, and there is a bond. Okay, so the total shape appears to be a T shape. And one more important thing, there is a lone pair of electron here. Because of this lone pair repulsions coming in this way, so you are going to see the bond angle is not equal to 90, less than 90, because the bond comes little down. Hi, probe hacked. Lone pair meaning a pair of electrons which do not participate in bonding is called as lone pair. Bond pair means the pair of electrons which participate in the bonding is called as a bond pair. बच्चों समझ में आ रही क्या? Okay, right. Any doubt? So I am going to explain any kind of doubt as per your requirement. Don't feel this is a small doubt or a big doubt. Okay, coming to PF5. PF5 आपका जैसे PCl5 का जैसा होगा. It is just like a PCl5. It is going to have trigonal bipyramidal. Okay, and it is going to be TGBP. Okay, trigonal bipyramidal. And also students, XeF4, you are going to have total valence electron. Xenon, however, it is a noble gas. It participates in bonding. Noble gases do not participate in bonding, but noble gas here, xenon, is going to participate in bonding in a rare conditions. In the rare condition means at extreme conditions, it is going to form 3-4 compounds with either fluorine or oxygen, that we are going to discuss in the p block elements. So, coming to xenon tetrafluoride. So, it is going to have sp3 dihybridization and it is going to be square planar. Whenever it is sp3 dihybridization, lone pair can come here, lone pair can come here, lone pair can come here. If this is the case, so the arrangement is different possibilities. Which possibility is the best possibility? This is not the best possibility. This is not the best possibility. And this is the best possibility, because the arrangement of the electrons will be in such a way that there is a minimum repulsion among them, right? And talking about XeF2, it is also undergoing sp3 hybridization. You can see, dear children, xenon has 1, 2, 3, 4, 5 and 6, 7, 8. Okay, fluorine, and it is going to have a fluorine. So, 3 lone pairs and 2 bond pairs. So, it is going to have the linear shape. And I just want to talk about the steric number. Steric number is equal to total number of electron pairs around the central atom. Steric number is equal to sum of the lone pair number and the bond pair number. This is what is called as the steric number. Steric number gives you the geometry of the molecule, while the only bond pair gives the shape of the molecule. So, geometry of electron arrangement. While the bond pairs is going to give you the shape of the molecule. That is the difference between this lone pair and the bond pair and the steric number here. And most of the cases, students are going to confuse about what is the steric number and other kind of things. Okay. So, moving ahead, PF2Br3. My dear students, we started beryllium chloride and they are going to hit PF2Br3. So, we are going to see sp3 dihybridization. It is a trigonal bipyramidal structure. So, fluorine kaha rakhna and bromine kaha rakhna. That is the key point. So, we are entering into the difficult type of examples. So, I just want to give you a trick. Whenever multiple bonds are coming, whenever more electronegative atom or small atoms are there, it has to be placed in trigonal bipyramidal structure. It has to be placed in equatorial positions. And also you can see trigonal bipyramidal structure, and you can see PO4 3 minus, you have various number of resonating structures with, that is a tetrahedral structure. All phosphorus molecules are going to have, phosphorus acid molecules are going to have tetrahedral structure. Okay. And also you have NO2 minus, it is NO2 minus is going to be bent structure. You are going to see the bent structure. You are going to see CO3 2 minus can have various resonating structures. In this resonating structures, sp2 hybridization, and it is going to be a planar trigonal structure. Okay. And also you can have the formal charge and the bond orders are also given. The formal charge on each oxygen atom is going to be -2/3 and bond order is going to be 1.5, and it's very important we are going to struck at this point. Okay. So here, but carbon has 4 valence electrons of these 3 form sigma bonds, therefore rest will form a pi bond. Oh yeah, is my Navashi, is my voice is low? You please just check your internet. From my side, voice is fine. Okay, talking about BF4 minus, you just see various examples here. It is going to have tetrahedral Navashi, okay, and Accord and Mita and Hari Krishnan. Come on, let's find out it is a tetrahedral BF4 minus. Can you find this is going to be a dative bond? I want to say BF3 plus F minus is going to give rise BF4 minus. Okay? Your phone volume would be full, but maybe due to data and the bandwidth of your internet, the voice is coming low beta. Don't worry, you can watch the recording if you feel it is highly recommended. And you can see the other one, ClO3 minus. It is an odd electron species. Odd electron species. It is going to minus, no? ClO3. No. It is an even electron species only. And you can see it is a minus. ClO3 is odd electron species. Okay, you can see it is going to be a pyramidal in the structure. The structure is going to be pyramidal. It is going to be pyramidal. Okay, and also moving ahead, XeO2F2. Total number of electrons are 34. Requirements 4 sigma bond, 1 lone pair of electron. And it is going to be, if lone pair is there, you just place in equatorial position. In this equatorial position, you can write this is Xe. Okay, it is going to be F and F double bond O and double bond O, and here it is going to be lone pair of electron, and it is going to be distorted trigonal bipyramidal, and it is going to be seesaw structure, seesaw geometry, and इसका structure आता है आपका SF4 का बराबर होगा. Which of the following has the equal structure with SF4? And you have to see the twist. You have to find the two structures which is actually equal, right? And talking about XeO3, it is going to be pyramidal. It is going to be pyramidal, right? And a lone pair of electron is there. And you can see XeF4, XeOF4, it is going to be square pyramidal. And the lone pair is there on one of the orbital, and it is a square pyramidal. Okay. And also this is the total picture about the VSEPR theory. A is the central atom and B is the bonded atom, E is the number of lone pair of electrons, where A, B to E, 2 bond pairs, 1 lone pair, it is going to have V shape or bent shape or angular shape, and these are the various examples. AB3E, AB2E2, AB4E and AB3E2 and AB2E3, AB5E and AB4E2 and AB6E. E stands here, lone pair of electron. But it's very important, this particular slide can give you very important site for finding questions in VSEPR theory, and it is utmost important for NEET examination. You can crack any multiple question based on this. I request everybody take a screenshot of this. 3, 2, 1. Along with examples, you are going to get it, right? So that's it. Very important, bacho. And we are done from this VSEPR theory in today's class. And in the next class, I just come out with finding hybridization and molecular orbital theory. If you have any doubts, please let me know, so that if you still find any difficulties, mention in the comment box also. Please attend our classes on a regular basis on the live sessions. And still, if you have any doubt, you can mention in the comment box. By any chance, if you are not able to attend the class, you watch the recording. After recording also, if you have any doubts, please use the chat box, and you can comment box, you can mention there. And we are done from our side. Signing off, Suresh, Faculty of Chemistry from Infinity Learn NEET YouTube channel. Please like this session, share with your friends, and subscribe to NEET Infinity Learn channel. Thank you. Bye bye.